Guess I don't get my slides. Okay. Hey. Is everyone tired right now? I'm so tired. I'm going to try to keep you guys awake. As a warning before I get started, if you do start to doze off, there's a high likelihood that you're going to fall out of your chair at some point. You'll see why in the future. So getting started, my name is Zack Argyle. I currently work for Pinterest. I worked for PlayStation before that. At Pinterest, I've been there for about 3 years, and I'm currently working on our new mobile web version. So think Twitter Lite, but for Pinterest, and we're making that happen right now. So when I'm not at work, I'm a dad.
You scare my son.
This is me in real time.
Roar! I'm Batman.
He does love me, I promise. When I'm not terrorizing him, I'm trying to get him to learn to code. Sometimes it doesn't go well.
Spell. Oh, that's not what we wanted to spell.
Oh.
Oops.
So that's me. Good times. All right, so today we're going to talk about a couple different things. Eventually, the idea is we're going to get to the point where we can render a offline React app using ServiceWorkers and App Shell and Redux Middleware. So to get started,
work, 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 work. You see me heavy work, 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 work. You see me do me dirt, 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 dirt. There's something about that work, 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 work.
You're awake. Okay. That's going to happen a couple more times. I figured I was at 5 o'clock the very first day. Like, everyone's tired, so that's like, be warned. All right, so ServiceWorkers. How many of you have, know about ServiceWorkers, have heard about ServiceWorkers before? All right, like a good chunk of you guys have heard about ServiceWorkers. How many of you have used ServiceWorkers before? All right, like maybe 5%? And how many of those 5% have written your own service worker? All right, like 0.5% maybe? All right, yeah, they're funky. They're really low level, and like in general, we don't write them on our own. So we're gonna talk about it really quick. Service workers to me are essentially the secretary for your app. So the way I think about it is that if you've got your app and you've got your server, any request that wants to be made to your server is going to go through your service worker. And as much information as you give to your service worker allows them to make requests for you. So like if you I don't know if you can read this, it says, "Hi, Mr. Worker, can I talk to Mrs. Pinterest?" "Of course, what would you like to speak about?" "I want to visit her home and get some pinspiration." "Well, I can do that. There's no need to bother Mrs. Pinterest." Beep, boop, beep. "Well, that was fast. Bow to the glory of service workers." Thank you. I was like both embarrassed and proud of myself when I made this. So there you go. Yeah, so the idea is that the service worker can take care of things for you without having to go to your server, which is exactly what we want when we want to do something like an offline experience, because we cannot go to the server. That's the whole idea. So service workers have a lot of things that they enable. If you're not familiar with service workers, the way it works is, actually let's skip over to this next slide first, and then we'll cut back. So a service worker is essentially a sidecar process that runs in another thread. It's like a web worker that Jana talked about. And it can register different things because it's running separate to your website. So it's running in the browser, but not as part of your web app. Your web app registers it, so it's like it's hiring the secretary, but the secretary is always on duty even when you're at home sleeping. So that enables a couple different things. First, it's basically this network proxy for you, right? It's like everything is going through there. It's kind of like a middleware for your server. It allows pre-caching, so when you install your service worker, what it can do is if you've given it enough information, as soon as it's installed, even when you're doing other things on your app, it can go and fetch things and pre-cache them for you. So like all of the assets that you've generated through your build, so like your JavaScript, your CSS, maybe an app shell, you can go and fetch those immediately as soon as the service worker is installed, before they even make the requests for those. So the next time around, you have all of that already cached. The third, runtime caching. This one's really, really important. This is what kind of enables a lot of what service workers do and why people like them. So runtime caching essentially says, because I'm a network proxy, because I'm sitting between your app and your server, any request, I can do whatever I want. Whatever you tell me to, I can do it. So we're going to talk about a couple different things that, a couple different runtime strategies for caching. So push notifications, if you've ever had, I'm sure you've gone to a website and they say, hey, can we send you push notifications in the browser? And you're like, nope. They've got a service worker installed. That's the way it works, right? You can't, because it's running separate to your app, because it's the secretary, even while you're sleeping, even while they're not on your site, they can receive those notifications and send the push notifications. So that's why those are important. Background sync is an interesting one. The idea being that for async calls that you are worried might not go through, like so if you're offline or if you're in like a sketchy network environment, you can send these basically messages to your service worker to say, hey, you go make this request whenever you can. Like I'm going to optimistically say that the request went through, but I'm really going to tell my service worker to go, as soon as you can like make this work, if I'm offline, as soon as I come back online, you make this request, you go send this tweet, etc. And all of that enables essentially offline network management. So today we're specifically going to talk about how to, in the most basic sense, enable offline reading. There's also a lot about how to do offline writing, but that gets a lot more complicated, so we're not going to go into that today. No time for that. Everyone wants to go get some food. All right, so some of the FET strategies for runtime. These all, I mean, they kind of make sense, and I'm going to try to go quick because I want to try to get us out of here on time if possible. Prefer cache essentially means if it's in the cache, use it. Cache only means if it's in the cache, use it. If it's not, throw. Offline only means make the request, store it in the cache, and then if that same request is ever made, return the cached information only if I'm offline. Network only says don't cache anything. So this is like essentially if you don't have a service worker, everything is network only. That's the default. Race/fastest, this one is really, really interesting. So older phones, because their CPUs are so slow, it actually can take longer for them to go look up something in the cache than it actually takes to go make the network request. So you can race them. You can say at the exact same time, I want to like make a parallel request to the cache and to my server, and whichever one comes back first, return that. Which seems really weird, but it's a thing. All right, so this is all it takes to register a service worker. You just got to check to see if it's supported, because sadly, there are still unnamed browsers that don't have them supported. But it's really easy to do. All you do is you point to the URL of the service worker. It has to be hosted on your URL, on your domain. So this would be .com/sw.js. That's what that path would mean. And they're all scope-based, so you usually want to install it at that /something.js. An example of what it looks like to precache. Essentially, you're saying so this is inside of the service worker code. You're saying when I install, don't finish installation until I've opened a new cache, and then I've gone and made fetches for all of these items, and I've stored them in cache. That's essentially what that means. It's fairly straightforward, which is kind of cool. The cache.addAll is a little more recent than previously, but you can also just go fetch and then manually put them in the cache. But the cache.addAll makes it really kind of nice and clean. Yeah. So looking at these assets that we have right here, right? These are like hard-coded static/main.css. Like that's not a real thing that we have. All of our assets are pretty much for production all revisioned, which is why we have a lot of these tools for service workers and why most people don't write their own service worker. So popular ones are offline plugin. Well, that's probably, I think, the most popular one. Service worker Precache is built by Google. That's right up there with offline plugin. Workbox is a newer one. Google is essentially saying, we realize that building service workers is really hard, so what we want to do is we want to create this workbox or this tool set of things for people so that they can build service workers on their own. So that's what that is. It's a bunch of different tools for building service workers. There's a lot of really interesting things about doing service workers that aren't like built in like manually. It's like if you want to cache images, there's no like good way to set an expiration on when that cache is going to expire. So you have to like use IndexedDB. So Workbox kind of gives you some nice ways to not have to deal with IndexedDB and everything by yourself. Service workers is it's 3 libraries that I open source through Pinterest. The one that I think is most helpful outside of offline plugin and service worker Precache is there's one called Service Worker Mock. So if you do write your own service workers, It allows you to basically inject a ServiceWorker environment. They have their own special environment in the worker, and it's really hard to test them. So it basically makes it easy to test your service workers. So.
Go ninja, go ninja, go! Go ninja, go ninja, go!
I swear they're all like very loosely connected to the side. Right, shell. It's close enough, right? If you look really closely, you'll actually see it says Ken Wheeler on there. I figured he probably likes Ninja Turtles, so. Anyway, going on. That one fell flat. All right, so what is an app shell? An app shell is essentially a HTML blob. It's usually fairly small, it's generic, and it's cacheable. That's the main thing. We want some chunk of HTML that we can cache, that we can reuse for all of our app. And the reason we want to do that is for our service workers, so we can cache it there and serve it up later. We want this to be something that will progressively load the rest of our app. Right? So these are some examples of things that could be app shells. Something that like you can immediately render to the page, and then the rest of the page will fill in once we decide like what URL we're in and what we're doing. A side benefit of app shells is the time to first paint is very quick because you're not doing any server rendering. A side note to that is it usually means that the time to full paint, or like the time to full content ready, is usually slower because you haven't server rendered. Fourth, immediate repeat loads. So that's the big benefit. Once you've got this thing cached in your service worker, I can return it before even going out to the server. Right? I don't need to go to my server anymore. I've got my app shell. So when you go to flipkart.com, within like, I don't know, 50, 100 milliseconds, you've got something on the screen immediately there that's going to go fetch the rest of the content, which is really, really great. And the final benefit is that because we have this HTML that's cached, that has information about all of the CSS and JavaScript we need, we can serve this thing offline. And if we have the JavaScript and CSS pre-cached, like we were showing earlier, we can actually render the entire page, which is awesome. So this is an example. This is the app shell for Create React App. As you can probably see, it's decently large. Basically, it's a div that's going to point to what is going, like where we're actually going to render the React content, and a script and a CSS file. You can see that those are revisioned. Create React App by default has service workers installed for production mode, and it's using service worker precache. And so for the demo that I'm going to show later, we're actually going to use Create React App to show an offline app. It's kind of cool. I don't have my notes, so I don't remember what the warning was right here. Oh, I do remember what the warning was. So the warning is, oh yeah, there's also that. It's there. If you care about SEO, app shells are kind of a gotcha. You do, so it's tricky. I've talked with a bunch of Google folks because they've pushed app shells very, very hard. And what I've been told is, we can't give you SEO advice, but you should probably continue server rendering. So that's what I'm telling you. Yeah, if you care about SEO. If you don't, Facebook doesn't care. They can do app shells all day.
I'm squeezed in the middle.
Remember this song?
In the middle.
Chips Ahoy commercial?
In the middle. Smack dab in the middle.
It's so bad. It's also weird because I can't see what slide's coming next, so I can't even give you a warning that there's going to be a loud sound. All right, so Redux/Redux middleware. How many of you say you have like a B or A grade in your Redux knowledge? Whoa. Dan raised his hand. I hope so. I hope so. All right, so quick overview. If you have more questions, bug Dan. But the idea of Redux is essentially you've got, and the way I think about it is Redux is essentially like a client-side database. I prefer all of my Redux data to be normalized, so it really kind of looks and feels exactly like a database. So you've got this store of information, and From your app, you're going to dispatch some action that's essentially a transaction with the database to make changes to it. That action can update anything in the database. It can update multiple things, but that's essentially what Redux is. It's a database that I'm going to dispatch actions and make changes to. So for our purposes, what we care about is the middleware section. Most people don't write their own middleware. It's actually fairly easy to write middleware, and we're going to see that I think the middleware that we're using for our demo is 4 lines, something like that. It's pretty small. And where it sits is essentially between the dispatched action and the store. Well, I guess yeah. So essentially it gets exactly when the dispatched action happens, and then after all of the changes have occurred is essentially where the middleware sits. So it has access to both sides. All right, so this is what our middleware looks like that we're using for the demo. Essentially what it's doing is saying, if you look down at the bottom, that's the actual middleware. I called it persist. It gets access to the store. Next is essentially saying for all the other middlewares, we just want to tell you when we're done in case this is going to be an async middleware. And then you get access to the current action that was dispatched. And I'm saying I don't really care about the action. I want to just let it do its thing. And then once all that's done, I want to maybe persist the state. So I'm debouncing it just because stringifying stuff, especially if the store is really large, can be kind of slow, and I don't want to do that all the time. So I'm saying at most every 500 milliseconds, I want to take my entire store and I want to stick it in local storage. Now, this is probably not what you want to do in production. You probably want to be a little bit smarter about that, and there's some libraries that make it a little bit easier to decide what you actually want to persist. There's one called Redux Persist. That's pretty nice. I've got links at the end of the slide for these. Yeah, all right. So moving on, this is our Bootstrap code right here for our app. And essentially what we're going to do is when we're creating our store, and this is when your app is initially loading, when we're creating that initial state for the store, we're going to say, so in this example, we're saying if I'm offline, use all that cache state that we have. We took that store and we stuck the whole thing in local state. So if I'm offline, I just want to reuse that. So immediately, I'm going to have access to the entire session that you had previously. Yeah, pretty straightforward there. I'm going to skip over this just because I want to not spend too much time on that. All right, so here's this demo. Links in the slide. I'm going to tweet this out later today, so if you want to check it out, the code's up on GitHub as well. This is our little mini app. So Pinterest has these widget APIs that are open. So if anybody wants to embed a widget on their site, we have these completely open APIs. So I'm using one of those to grab one of my boards. This board is called Sexy Steaks. I like steak. I've got some other ones like travel ideas. Oh, I don't have internet connection right now. Let's see if it'll let me connect it automatically. Nope. Sheraton will All right, let's reload that. Cool. I've got a men's fashion board. I've got how about my man cave board? That's pretty good. Okay, so let's look at what's going on here. If we take a peek here, yes, I will make this larger. A little bit bigger even. All right, so if we look in the application tab, we see we've got this ServiceWorker installed. So over in the application, you see ServiceWorker. We've got a ServiceWorker installed. We can also come into the cache storage and see that we pre-cached a couple items. They're kind of far away. It's the CSS, JavaScript, and the app shell. That's what those three are. And then here, we are runtime caching all of the images that are requested. If we want to take a look at what Redux looks like, this is there we go. You can see we've got we know which requests we've already made. These are the feeds, which are basically just these IDs and the type. We've got all the pins that we've requested. And this session is just saying where are we currently at. We can look at what's in local storage right now, which is essentially that entire store, right? So we've been persisting it. So now, if I click offline and I reload the page, did you even see that? That's reloading and re-rendering the entire page that fast because we have the app shell, we have the JavaScript, we have the CSS, and we have the entire session store that we had already built up. That's pretty cool. Yeah, and because we have that entire session, we can actually go and say, hey, we already looked at this stuff. So all of these things we've already been to, we have them all in the store still. So like they can go around reading all of the stuff that they've already seen. Oh, hey, there's Ken Wheeler right there. Cool. All right, so that's the demo. I hope you've realized that it's not that difficult to get offline reading going, particularly if you've got like a normalized Redux store, which I think is really nice. Some links to use. If you're interested in doing offline writes, I would definitely suggest reading the Redux offline documentation. It's really, really great. It has a lot of good information about that. The network information API will let you know like how good the network activity is. Background sync information and Redux persist. If you're interested in doing any of this stuff, I would suggest using that.